Hello friends, through this video some multiple choice questions based on chapter first, which is of real numbers, have been taken for discussion. So let's begin. Question number 1. The decimal expansion of 23 upon 2 cube into 5 square will terminate after 1 decimal place, 2 decimal places, 3 decimal places, or 4 decimal places. For this, we shall proceed as here 23 upon 2 power 3 5 square. This can be expressed as 2 power 3 into 5 square into 5 into 5. I have multiplied the numerator and denominator by 5. So it is 23 into 5, and this is 2 cube into 5 cube, which can further be written as 2 into 5 whole cube. That is 5 3 is 15, 5 2 is 10, 111 by 10 power 3. This is 1000. Since here there are 3 zeros, so decimal will replace 3 places towards the left side. So its answer will be 0.115. It means our answer is 3. C. The decimal expansion of 23 upon 2 cube into 5 square will terminate after 3 decimal places as seen from here. Next question. The rational number 129 upon 2 power 5 into 5 power 7 into 7 power 5 will have a non-terminating repeating decimal or terminating repeating decimal or terminating decimal, all of the above. Which one is correct? Since this is a rational number because it is in the form of P by Q. Also, there is no common factor in numerator and denominator because 129 is itself a prime number, and the prime factorization of the denominator is not of the form 2 power m into 5 power n. Due to excess presence of 7 raised to power 5, this will have non-terminating repeating decimal expansion. If the prime factorization of the denominator is 2 power 5 into 5 power 7, then it will have terminating decimal, otherwise it will have non-terminating repeating decimal. So our option A is correct here. Next, 3 plus 2 root 5 is an irrational number, neither rational nor irrational, whole numbers. We know that the product of a rational number and an irrational number is an irrational. So 2 root 5 is an irrational. Now the sum of a rational and an irrational is also an irrational number. So here option A is correct. Third, completed. Fourth, the square of any positive integer is either of the form 3m, m is an integer, or 3 plus m, 3m minus 1, 3m plus 1, m minus 3. To proceed for this question, we take a square of positive integers, like 1 square is 1, 2 square is 4, 3 square is 9, 4 square 16, 5 square 25, 6 square 36, and so on. Now we have to check whether these numbers have the form 3m or which one more form. Clearly, if we take m as 0, 1, 2, 3, 4 like this, we get 3 into 0, that is 0, 3 into 1, this is 3, 3 into 2, 3 to 6, 3 3 ja 9. It means this 9 is of the form 3m. Now we have to check for other numbers whether they are of the form 3 plus m or 3m minus 1 or 3m plus 1 or m minus 3. So here 1, for this 1, this can be written as 3 into 0 plus 1, that is 1, and for this 4, this can be written as 3 into 1 plus 1. It means these numbers are of the form 3m plus 1. So our option is C. If we take 3m minus 1, there will be some negative integers, so it will be ignored. Similarly, m minus 3 will be ignored because this gives negative integers 2. If we take m is equal to 0, 1, 2, then the result for this will be some negative integers, but in our question the condition is positive integer. Question number 5. For a and b being co-primes, then a square and b square are also co-primes. So our option C is correct. For example, if we take a is equal to 2 and b is equal to 3, these are co-prime numbers. Their squares 2 to the 4 and 3 to the 9. These are a square and b square, they are also co-primes. This is true for every pair of co-primes. So option C is correct. Now question number 6. In Euclid's division lemma, a is equal to bq plus r, where r is less than b and greater than or equal to 0, the number a is dividend. So option B is correct. B is the divisor, q is the quotient, r is the remainder. Here a is dividend. Question number 7. In Euclid's division lemma, a is equal to bq plus r, where r is less than b or greater than or equal to 0, the number r is the remainder. So option D is correct. Next question. For an integer m, every even integer is of the form. Every even integer of the form 2m. So option D is correct. For example, if m is equal to 1, then 2m, that is 2 into 1 is this even. M is equal to 2, 2 into 2 is equal to 4, this is also even. M is equal to 3, 2 into 3, this is 6, this is also even. So 2m will be an even integer for every integer m. Next, For an integer q, every odd integer is of the form. For an integer q, every odd integer. In question number 8, for every integer m, every even integer is of the form 2m, and hence for an integer q, every odd integer is of the form 2q plus 1. So option B is correct. For example, 2q is always even as stated here. If we add 1 to an even integer, we get an odd integer. So 2q plus 1 is always an odd integer. So option B is correct. Question number 10. If a and b be two odd prime numbers, a and b be two odd primes, let us suppose that a is equal to 5, b is equal to 3. These are two odd as well as prime numbers. Look at the example, a square minus b square, which is 5 square minus 3 square, that is 25, minus 9, which is 16. If a and b be two odd integers, then a square minus b square is, this is composite. So our option D is correct. Next, if the least prime factor of a is 3 and the least prime factor of b is 7, then the least prime factor of a plus b is, let us suppose a is equal to 3 and b is equal to 7. Their prime factors are 1 and 3. Their factors are 1 and 3. Similarly, factors of 7 are 1 and 7. 1 is taken neither prime nor composite. So only prime factors of a and b are 3 and 7 here, which is least also, because the factor 1 from both the numbers has been removed. So 3 and 7 will be respectively the least prime factors of a and b, where a is equal to 3 and b is equal to 7. Now a plus b, that is 3 plus 7, which is 10, and its prime factors are 2, 5. So least prime factor is 2. So we can say that the least prime factor of a plus b is 2. Question number 12. Cube of any positive integer is of the form 9m or 9m plus 1 or 9m minus 8, 9m plus 8, 8m plus 9, 8m minus 9. Here, cube of any positive integer is of the form 9m or 9m plus 1 or which one other form. Clearly this is 9m plus 8. The reason is, if m is equal to 0, then 9 into 0, this is 0, this is 1, and this is 8. This is the cube of 0, this is the cube of 1, and this is the cube of 2. So this gives a cubic number. On the other hand, 9m minus 8 will give minus 8, which is not a cube of any number for m is equal to 0. Similarly, 8m plus 9 for m is equal to 0, this gives 9, which is not a cube of any number. Similarly, 8m minus 9 is not gives a cube of any positive integer. So our option is B. Question number 13. N square minus 1 is divisible by 8 if n is an odd integer, an even integer, a natural number, any integer. Here n square minus 1 can be written as n plus 1 and n minus 1. Now proceeding from the given options, let us take n as an odd integer, means taking n as 1, 3, 5, 7, 9 like this. So the value of n square minus 1 for n is equal to 1, 1 plus 1, 1 minus 1, this gives 2 into 1, 2 into 0 means 0. Then n is equal to 3, 3 plus 1, 3 minus 1, that is 4 into 2, that is 8. This is divisible by 8, this is divisible by 8. Now for n is equal to 5, 5 plus 1, 5 minus 1 means 6 into 4, 24, which is also divisible by 8. So our option A is correct. No need to take other options as we have found A as our answer. Now question number 14. The least number that is divisible by all the numbers from 1 to 10 is, the required number will be the LCM of the numbers from 1 to 10, and which is 2520. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 1 into 1, 2 into 1, 3 into 1, 2 into 2, 5 into 1, 2 3 is 6, 7 1 is 7, 2 into 2 into 2, 3 into 3 and 2 5 is 10. So required LCM will be maximum factors 2 into 2 into 2, then 3 into 3, then 1 5 and 1 7. So 2 2 is 4, 2 is 8, 8 3 is 24, 3 is 72 into 5 into 7, 2520. Now question number 15. If two positive integers p and q can be expressed as p is ab square and q is aqb, where a and b being prime numbers, means this is the prime factorization of p and this is the prime factorization of q. So LCM of p and q will be the factors having more powers, like a cube into b square. So our option is C is correct here. This is all about the questions taken in this video. I hope that you would have enjoyed these questions. Thank you for watching this video.